Friends, welcome to part 1 of our video presentation on big data. Now this part, together with part 2, is based on a tutorial or an article by Watson published in the Communications of the Association for Information Systems journal. And this tutorial is available for you through Canvas as well. So both of those parts are largely based on this tutorial. In the first part, we will largely talk about the so-called managerial perspective on big data. So we'll try to define what big data movement is all about and what kind of organizational or business considerations go into that movement. In other words, how this movement was created, how big data analysis can create value for an organization, and so forth. So this is largely an introduction to big data and also an overview of some of the managerial issues surrounding big data. Now, the technical part of big data will be discussed in the second part of this video presentation. Okay, some introductory remarks. Today, many organizations are collecting, storing, and analyzing massive amounts of data. Now, those massive volumes of data are commonly referred to as big data, because it's big, it has high volume. It also has a high velocity of creation. In other words, the velocity at which the data arrives, the velocity at which this data is created is very high. And also variety, meaning this data takes a variety of forms. It can take a form of a video, of an audio file, of a Twitter feed, textual information, transaction data, and so forth. So there's a variety of forms as well. This big data creates new generation of decision support systems. The kind of decision support systems that instead of relying on a sample of data, for example, take into account the population of data. In other words, instead of taking a sample of transactions from a retail location, those DSS applications, they analyze all transactions. So it's a different type of decision support systems. The systems that operate with huge volumes of data, and the expectation is that those manipulations, that analysis needs to be done in real time. Now, businesses are increasingly recognizing potential value of this data and are putting technologies, people, and processes in place to capitalize on the opportunities afforded by big data. In fact, I would go further by saying that nowadays a lot of experts, a lot of managers, they view big data as a strategic resource. So basically they're saying that a lot of organizations nowadays, they're not just sitting on data, they're sitting on a strategic resource similar in value and significance to oil and financial assets such as money. If you read the popular press like the New York Times, the Wall Street Journal, Financial Times, Economist, a lot of them saying that data will be the most strategic asset of the 21st century. Companies will compete based on data, based on their understanding of their internal and external environment. It is also something that has been discussed in books. Nowadays there's just so many books published on the topic of big data and business intelligence. But the book that is worth mentioning is Competing on Analytics by Tom Davenport. So this is the book, and this is Tom Davenport himself. I think this book was published in 2007, around that time. And but Tom Davenport, he has been talking about business intelligence, about using data for creating competitive advantage for a long time. I attended one of his presentations. But arguably, this book laid the foundation for this whole business intelligence, big data movement. And I think that for anybody in the area of data science, business intelligence, or big data analysis, this book is a must-read. And I think a lot of people have read that book. So here we have, this book outlines some of the managerial, conceptual, and perhaps even philosophical foundations of business intelligence and big data and competing on analytics, which is the main subject matter of this book. Just like some historical, perspective on big data. Now, collecting and storing big data is of little value. It needs to be analyzed so that value is created. But business analytics is not new. Many analytical techniques such as regression analysis, simulation, text mining, machine learning, they have been around for many years. I think regression analysis has been around for like 200 years now. So what is new about big data? Well, what's happening is that several things are coming, several pieces of the puzzle are coming, together now in relation to big data. First of all, you have amazing advances in computer technology and software, where technology nowadays is very sophisticated and at the same time very reliable and relatively affordable. Then you have new sources of data, the kind of sources that were not available even 10 years ago, such as social media. Then you have businesses increasingly realizing that you can base strategies for outperforming competitors, for improving customer service, on data alone. So those three characteristics, they define or they lead the foundation for the current big data movement. And the reason I'm saying big data movement, because personally I believe that big data is not just about data and tools. I mean, it's that whole organizational movement that of course uses technology, but also relies on creating new processes for analyzing this data, hiring people with expertise in data analysis and technology supporting data analysis, and also formulating data-driven strategy. So that's why I'm saying it's a big data movement, meaning it's like a managerial fashion or organization-wide initiative that companies are pursuing nowadays, not just data itself. Now, big data also creates a lot of will create a lot of employment opportunity. At least that's what some of the studies predict. I think The Economist said that statistician will be like the most in-demand job of the 21st century, with statistician being broadly defined as somebody who can do data analysis. So, for example, a study by Gartner predicts that big data movement will create 4.4 million jobs globally, and 1.9 million of those jobs will be created in the United States. And for every IT job created, there will be an additional 3 jobs, generated that would support, data analysis roles and the positions of data scientists. McKinsey Global Institute is not, that pessimistic. That is not that optimistic, but still, they're predicting that there will be a shortage of 140,000 to 190,000 of people with deep analytical skills, as well as 1.5 million managers and analysts to analyze big data and make decisions. So because of that, universities, they see this as an opportunity. They're offering courses and degree programs teaching skills that are related to the big data movement, and those skills are related to statistics, databases, data analysis, data mining, and so forth. Now, similarly, technology vendors such as IBM and SAS, they partner with universities, to get exposure for their data mining, business intelligence, and big data products, so that people, who study in those programs, once they learn more about those products, they utilize them in the workplace when they graduate. I've been enrolled in one of those programs from the University of Illinois in Urbana-Champaign. Actually, I just completed a Coursera online certificate on data mining, and I've learned quite a bit about the data mining aspect of big data and how to work with large textual data sets, using limited computing resources that I had, which is my desktop computer. Another specialization that I'm enrolled right now, I haven't finished it yet, is the one from the John Hopkins University, and that specialization is on, I would say, pure data science using R. So largely it's about using R language for addressing some of the data problems in the workplace or in science. A few comments about the relationship between big data and business intelligence. Now, on the surface, big data and business intelligence are similar concepts, but there are some differences with respect to the following areas. I would say big data is much broader than business intelligence, because business intelligence largely involves data and analytical tools. Now, in addition to analytical tools, big data movement involves addressing personnel issues, meaning training people, hiring people that have expertise in big data. Also addressing data architectures, because traditional BI architectures may not be able to accommodate big data characterized by those 3 V's that we'll discuss in a second. And also addressing privacy concerns, because with big data being available, there is more information that can be derived about each individual, and some of that information can be viewed as sensitive or confidential. So privacy is a very important aspect of big data. So what is big? So once again, after talking about all those background details about big data, so let's try to define what big data is. Now, a lot of people define big data in terms of the 3 V's, meaning it's data characterized by high volume, which is the amount of quantity of data, refers to the amount of quantity of data, high velocity, meaning the rate at which data is created, and high variety, meaning the different types of data that that is captured and stored, like audio data, textual data, video data, and so forth. Now, big data, meaning like big data sets, they're not a new phenomena. For example, some companies such as eBay, they capture terabytes of data. So, eBay not only captures terabytes of data per minute, a terabyte data per minute, it also maintains over 40 petabytes of data about their customers and their interaction with eBay website. So big data sets themselves are not new. So what is new? So what is new with big data? Now, you can understand what is new about the big data movement if you accept a broader definition of big data, that is explained here. So basically, to make this definition a bit broader, that would encompass the entire big data movement, the following can be said. Big data is a term that is used to describe data that is high volume, high velocity, and or high variety. Now also, big data movement requires new technologies and techniques to capture, store, and analyze this big data. And then the third aspect of the definition of big data is that big data is used to enhance it needs to be used to enhance decision making, provide insights and discovery, within the organization or outside of the organizational boundaries, and support organizational processes. So those three elements together, they define the entire big data movement, not just big data itself. So I think this definition of big data is much better, and I think this is where things are going. When people say big data, they don't just mean data that has high volume, high velocity, and high variety. They mean all those three things: new technologies, and also that organizational perspective where companies are increasingly using big data to gain insights, to gain new knowledge, and improve their competitive position. So where does big data come from? What are the typical sources of big data? Now, nowadays we're somewhere here where approximately an equal share comes from enterprise data, meaning organizational information systems such as ERP system, from telecom databases like voice over IP data, from social media, and then from different sensors and devices such as gas meters, temperature meters, and so forth. But it is predicted that in the future, and we're already approaching that stage, we're somewhere here in 2015, most of the data will come from social media and sensors and devices. So you've probably heard about this term Internet of Things, where all kinds of devices, like temperature sensors, cars, appliances, and even individuals using their cell phones are connected to the internet. And because they're always connected to the internet, they're broadcasting all kinds of information about temperature, about their location, about their activities. So all this data can be logged, can be captured, can be managed and analyzed in conjunction with other sources. And social media is also becoming a large source of information because there are just billions of people on various social media platforms such as Facebook, and they're generating text content in real-time fashion, and they're generating lots of it. So a lot of organizations nowadays are involved in gathering and mining social media data as well. But again, big data typically means combining all those diverse sources of data for subsequent analysis and for improving organizational processes and competitive position. So just like to enumerate on sources of big data a bit more, big data can come from web logs from a website, meaning a website logging all the interaction or browsing behavior of users, from social media, from machines like sensors, smart meters. A specific interesting subset of machine data is GPS data, created by phones, location-based data, and then also image, voice, and audio data. So all those things, they comprise, those big, complex data sets that many organizations nowadays are sitting on. Just again, some history or some perspective. In 1970s, this whole idea of capturing and analyzing data with the help of computers for the purposes of benefiting organizations in various ways was called decision support systems. By 1990s, decision support systems, or DSS term, kind of went out of fashion, and everybody started calling it business intelligence. Nowadays, everybody calls it analytics or business analytics. So what is analytics or business analytics? Well, it can be said, it can be argued that it's an umbrella term for data analysis applications, similar to BI. Or some people make a distinction that it is the getting data out part of business intelligence. So we talked about business intelligence before, and business intelligence involves both getting data in and getting data out, meaning getting some kind of analysis out of the data. So some people say that analytics is that getting data out part of business intelligence. So what are the common types of analytics? First of all, you have descriptive analytics, where you're trying to describe data. You have reports, simple summary reports. You have OLAP cubes, you have dashboards, you have various data visualizations. Now, this type of analytics, it's not very analytical, it just provides a simple description. But again, those simple descriptions can be quite useful. I mean, it may be quite useful for a manager, let's say, to understand summary of major customers, or summary of item sales within a store, because of that knowledge, further predictions can be made. But of course, the most valuable, in my opinion, type of analytics is predictive analytics, where you use data to predict things about the future. There are a lot of analytical models that are used for prediction. Regression is one of the most common ones. And there are many software applications like SAS Enterprise Miner that supports predictive analytics. Now, the reason I believe predictive analytics is the most valuable type, because if you can predict future, you can control future, right? I mean, if you know what customers will want 10 years from now, then you can adjust your organization to meet those demands. And by doing that, you will be way ahead of your competition. Then you have something called exploratory or discovery analytics, which means like you don't have any particular purpose. You're just mining data back and forth to try to find some patterns or correlationships. And that's typically called data mining. And then you have something called golden path analysis, but there are many other terms like event analytics, process mining, and we'll see some other terms, down the road. It basically involves looking at behavioral data. For example, data associated with the activities or actions of people, let's say on the internet or on a network. And based on those interactions, you identify certain patterns or events or activities that foretell customer actions. For example, based on certain activity pattern, you may predict that the customer will or will not renew cell phone contract. For example, if a customer within the last 3 weeks placed 3 complaints about quality of service and did not purchase any kind of add-ons from the website, then it means that the customer will cancel the cell phone's contract after it expires, or will not renew it, right? So that's like one example of a behavioral pattern being used to predict some important customer behavior, or closing a checking account, or abandoning an electronic shopping cart. So if you can do that, you can be proactive. In other words, you can try to correct that behavior. In other words, you can try to prevent a customer from leaving before he actually abandons the shopping cart. So maybe you can have like some kind of pop-up said, oh, by the way, if you purchase now within the next 1 hour, you'll get 10% discount. This can be done if you recognize that there's a high chance that the customer will abandon the shopping cart. Now, there are a few famous cases of companies using business analytics to improve their performance. For example, one thing that Starbucks does, along with many other companies, they do like those massive, they do this massive scale text mining or web mining, where they try to analyze what people are saying about them on the internet, probably predominantly in social media. Now, those robots, they don't actually read what people are saying. What they do, I think, they rely on sentiment analysis. Now, sentiment analysis is a technique in text mining that allows machines, computers, to identify sentiment within a message. So, for example, like in this paragraph, Starbucks is mentioned. So what the robot will do, it will analyze this message, this slide word for word, and it will assign an emotional score to every word. Like some words, they have like positive emotional score, let's say excellent, enjoyed, liked very much. So they will have like an emotional score between 1 and 5. And some words may have a negative emotional score. If something like sucks, terrible, will never come back, all those things can be scored with negative emotional score. And then like an average score is calculated for the entire paragraph or entire Twitter message or something like that. And then based on that, Starbucks can roughly know what people are saying, whether they're saying good or bad things about Starbucks. And if they're saying bad things about their new coffee, and that's what they discovered during one of their initiatives where they rolled out a new brand of coffee. They discovered that people liked it in general, they liked the taste, but they were complaining about expenses. They were complaining about cost. So they immediately reacted to it by lowering the price. So this was done by text mining, by analyzing all this data, that people leave on the internet in relation to Starbucks and their products. Another example of a company being successful in using analytics is Chevron. It's an energy company, or should I say oil company. Now, drilling, what they do, they explore oil, they look for oil, and drilling for oil is very expensive. It costs up to $100 million to just to drill one location, to see where the oil is there. And historically, their success rate has been 1 in 5. So in other words, they drill 5 times, they discover oil only on one drill. And if each drill is worth up to $100 million, it means that up to $400 million is wasted. Now, one of the geologists at Chevron, he took time, to look at the historical data, because Chevron, just like many other oil companies, keeps extensive historical data about geography, about different geological characteristics of different areas where they explore oil. So based on that, he was able to build a more reliable, more precise predictive model that improved their odds of finding oil on a single drill from 1 to 5 to 1 and 3. Now, needless to say, this model resulted millions and millions of dollars in savings. Then there is a company called USXpress. It's a trucking/shipment company. So what they do, they monitor trucks in real time, to see where they're going, whether they running engines without moving. So that's like undesirable idle time. So they try to minimize that, so that they minimize consumption of oil. Consumption of gas, and by that they minimize their overall cost. And they do a number of other things in real time by retrieving that real time data about trucks and their movement. Now, that's why some people add a fourth V to the characteristics of big data. They also say high value. So basically, in order for big data initiative to be a real big data movement, it needs to be high value. In other words, high value needs to be derived from volume, variety, and velocity, the other 3 V's. But of course, this value is realized only when an organization has a carefully thought out and executed big strategy. In other words, you cannot just do big data analysis for fun or for the sake of being fashionable, on board with all those managerial fads. There needs to be a very strong strategy. What exactly are you trying to accomplish as an organization? Are you trying to improve your customer service? Are you trying to react to customer needs in real time? Are you trying to predict the future and position yourself in a way where you as an organization is prepared for the future with your product offering? So there needs to be a clear strategy. How are you going to use big data to benefit your organization? Now, empirical studies find that companies that rely on business intelligence, on business analytics, they seem to be more successful than the ones who don't. So in other words, there's that relatively consistent finding in empirical literature that being a data-driven organization, relying on data, relying on big data to make decisions, to formulate strategies is something that pays off. So you can pause and you can just read about some stats about companies who do that, who rely on analytics, outperforming companies that don't rely on analytics. Now, it is also believed that big data can have a lot of opportunities for the government sector. Then just pause a little bit and read this quote from a report by Tech America. Okay, so after reading this quote, you probably get a sense of where people are going with this. What they're saying. Well, just let me step back a little bit. There's always that perception in the world of business that public services, government services, they're not as efficient as private companies, or at least that's the assumption. And economists explain that by the fact that because when people don't own something, they're not motivated to preserve it, to improve it. For example, if you own land, then you worry about maintaining that land, making sure it's not polluted, making sure it produces some benefit. But if you go to a public park, you don't own this park, so you may be more likely to vandalize something because people don't care when it's not theirs. So what they're saying big data can help the public sector improve its efficiencies. For example, there can be less crime because police force can use data analytics to predict crimes. They can use certain variables to predict whether somebody is likely to commit a crime, And once they can predict that, they can work with those people to make sure that those people actually don't commit that crime. So it's much better than, and much more efficient than reacting to a crime. I mean, waiting for a crime to happen and then trying to do something about it. Also improving traffic patterns, improving usage of other public resources such as water, maybe natural resources. So there is that belief that big data can help the government, the public sector with that. Now, what are some of the critical success factors in big data? In other words, what are the things that need to be there in order for a big data initiative within a particular organization to be successful? Well, first of all, there needs to be a clear business need for data analytics. I mean, it needs to be clear that how analyzing data will improve a particular aspect of organizational performance. Also, you need to have people who are skilled in the use of analytics, because you cannot do any analysis unless you have people who can do that. Also, you need to have strong, committed sponsorship so that your organization becomes a data-driven organization where everybody knows that all decisions that you make, all strategies that you propose should be driven by data. Also, you need to have alignment between business and analytics strategy. In other words, whatever your analytics team is doing needs to support some of the main goals or strategies or the overall vision of your organization. You also need to introduce a fact-based decision-making culture within an organization where people should not rely on intuition or opinions or their feelings when they propose a particular course of action. Everything has to be supported by real data. Strong data infrastructure is very important. You need, a lot of organizations have an outdated IT infrastructure or an infrastructure that is not necessarily outdated, but the one that cannot handle, big data volumes. And also the right analytical tools need to be there. Just like a few comments about finding a business need. Here you just have examples in various industries of how business analytics can be used, and you can just pause and look through those examples. But for example, in insurance or automobile insurance, analytics can be used to do like predictive models for client risk analysis. Who are the risky clients? Who is likely to get into an accident? Insurance fraud detection to see whether particular patterns of behavior in relation to insurance are associated with fraud that is subsequently discovered. Law enforcement, I mentioned that already, identifying people linked to known trouble groups, trying to predict their future crimes and trying to prevent those crimes from happening as opposed to waiting until they commit a crime. Transportation and logistics, real-time fleet management, just like that USXpress trucking company. You can use sensors in relation to that for real-time asset tracking, for knowing their location. Utilities, business analytics can be used to analyze, grid data to see, patterns of consumption. Based on that, you can adjust pricing or maybe save consumption, if sustainability or preserving of the natural environment is your goal. So all kinds of things can be done in all kinds of industries. It's just about finding a clear business need. Also, some additional comments on people, big data analytics users. If you want to pursue a big data initiative, you need to have three types of employees. First of all, you need to have data scientists, and typically an organization would not have many of those. I mean, sometimes there's just one data scientist who sometimes carries this title of chief data scientist or chief data officer or CDO. So this is somebody who with very deep analytical skills. And those analytical skills include statistics, business domain knowledge, let's say finance or marketing. Typically, those people have PhDs. They have background in hardcore research. They know everything about research methods and also complicated statistical models used for predictive analysis, machine learning, and so forth. Then you have analysts. Analysts are more applied. In other words, they may not have knowledge that is as deep and as specialized as data scientists, but they are practitioners. They know how to do practical data analysis, how to crunch data so that results that can subsequently drive decision making emerge. And then you have end users, people who are not necessarily analysts, they're not data scientists, meaning they're not as skilled in data analysis and related technologies and statistical analysis, but they know how to use data for decision making. In other words, they understand how descriptive reports, how predictive models can be used to benefit their job. So they need to be educated about benefits and about using the results of analysis and not necessarily in doing the analysis. So you need to have those three types of users or employees within your organization if you are to pursue a big data initiative within your company or within your organization. Okay, friends, so this concludes part 1 of our video tutorial on big data. Thank you for listening.